Hi guys, good morning or good evening. Today I'll be presenting the final project for Calculus Analytic Geometry 2. Okay, so let's go ahead and read the first question here. A missile fired ground level rises x meters vertically upward and in t second and 50 or in x is equals to 50 minus 6.25 t squared. Okay, so to find the initial velocity of the missile, we need to differentiate the function, so which is 50 minus x. Okay, x is equals to 50t minus 6.25t squared. So if we were gonna be looking for the uh, dx slash dt, so it should be 50 minus 2 and the 6, so it should be 6.25 t. Okay, all right, and then so it should be we will be multiplying these 2 and then 6.25, so it should be 50 minus 12.5 t. So to find the initial value velocity time is equals to 0, we must insert his value of time to the derivative of the function. Hence, the initial velocity is 50 meters per second. So how do we get that? So it should be dx, right, I mean dt, dx, so it's equals to 50 minus 12.5 t. So if we're gonna do that, okay, so 50 minus 12.5 is equals to 0. So it should be 50 meters per second. Okay, so that's how we get that the first the initial or that's how we get the initial velocity of the missile. So second, the time when the height of the missile is a maximum. So in order for us to get that, to find the time when the missile is at maximum height, we need to find the first differential of the function. So which is x is equals to 50 minus 6.25 t squared. Thus, we have 50 minus 12.5 is equals to 0, transferring 50 to the right side of the function, which has give us t is equals to 4 seconds. So, in order for us to, get that, one moment. So, so this is for the second question here. So in order for us to get that, so dt dx is equals to 50 minus 12.5 t, and then 0 is equals to 50 minus 12.5 t. So 12.5 t is equals to 50, so that will bring up to, or that will come up to 4 seconds. So this will be the answer for the first one. Okay. Oh, moment. This one is for the second one. Okay, so let's go to the third. Okay, one moment. Okay, so let's go ahead and go to the third questions here. So the maximum height reached and okay. let's check. So to find the maximum height reached by the missile, we need to use the time when it reached the maximum height, which is 4 seconds. Alright? So next, we need to substitute the value of time to the original function, which is x minus 50. Okay, so x is equals to 50t minus 6.25 t squared. Okay. Okay. Oops. T squared. Okay. And we will get the maximum height to be 100 meters. So, for this, 50 minus, so the time is 4 seconds. Okay, so it should be 4. So minus 6.25, and then the t is going to be 4, and then squared. Okay, so the answer for that will be 100 meters. Okay, so there, this is the answer for the third one. And on the fourth one, the velocity with which the missile strikes the ground. Okay, so right. Okay. Alright. So to find the velocity of the missile when it's hits on the ground, we need first to find the total time traveled by missile using the function of x is equals to 50t minus 6.25. Alright. Isolating t from both sides give us t is equals to 0. Okay. Which is the initial time, and x is equals to 0 when the missile is at the ground. Now we can solve the total time of travel using the new equation, which is 50 minus 6.25 is equals to 0, which has give us to 8 seconds. So let's compute that, or let's do the let's solve that one. So it should be 50t minus 6.25 t squared. Okay, by the way, this one is t squared, and then t is equals to 50 minus 6.25t, and then equals to 0. So t is equals to 0 because initially the missile is on the ground. Alright, so it should be 50 minus 6.25 t is equals to 0, and that will come up to t is equals to 8 seconds. Okay, now that we have the total time travel, we need to find the derivative of the function, which is dx divided by dx dt is equals to 50 minus 12.5 t, and then substitute the value of time travel, which will give us the final velocity to be negative 50 meters per second, or 50 meters per second downward. So let's go ahead and compute or do the let's solve that one. So dt minus dx, so 50 minus 12.5 t, alright, and then equals 50 minus 12.5. Okay, and then the t will become 8, and that will bring up to negative 50 meters per second. Okay, so the dx dt on this is going to be 50 meters per second downward. Okay, downward. Okay, so this will be the answer for the question number 4. Okay, so let's highlight that. So now let's go ahead and go to the second question. So a particle of unit mass move so that displacement after t seconds is given by x minus 2 cosine divided or multiplied to t minus 2. So now, find the acceleration and kinetic energy at the end of 3 seconds. Ke is equals to 1.5 mv squared. Okay, so right now, let's go to the second question here. So we are asked to find the acceleration and kinetic energy at a time, which is 3 seconds. So to find the acceleration, we must differentiate the function twice with respect to time. So the first derivative is for velocity and the seconds, with the value for velocity to be equals to 2 sine. Okay, let's go ahead and calculation for that. So it should be x is equals to 2 cosine, okay, minus t minus 2. Okay, so now so there yeah, there. So substituting the value of time t is equals to 3 to the function of acceleration give us I think let's compute that. For this, let's check. Yeah. So for this, since we will be this one, the velocity this one. Okay. Let me check. So yeah, for the answer number 1 here, let's get the velocity here. So dt dx, okay, is equals to 2 negative sine equals to t minus 2. So dt dx equals to t minus 2. Okay, so for this, the velocity on this will be negative 2 sine equals to t minus 2. Okay, there. So the acceleration function is the derivative of the velocity function with the respect of t. Okay. So let's add here, I think. Okay, let's check. A is equals to dt. Okay, dt dx. Oh, I'm sorry. Is equals to minus 2 cosine. Then 2 minus 2. Then dt dx. T minus 2. Okay. Then cosine is equals to negative 2 cosine t minus 2. Okay, so there. So that's for the that's how we get the initial here. Okay. And then what else? Okay. So, in order for us, by the way, in order for us to solve the kinetic energy here, which is this Ke, using formula Ke is equals to 1.5 mv squared, we need to substitute the value of the mass and velocity, which is 1 kg, and negative 2 sine multiplying t minus 2, substituting for the value of time, which is equals to 3 in the equation, which will give us 1.42. Let's try to solve that. Okay. Okay. So for the t, okay. So a, so this is the value for letter a, is 2 cosine times t minus 2 and equals negative 2 cosine 3 minus 2 minus 2. So for that, it should be negative 1.08 meters per second squared. Okay. So now let's go ahead and solve the kinetic energy here. Okay. So for this, oh, so I forgot this 3 seconds. So let's solve the yeah, this one is the seconds, this one, the number 3. So let's go ahead and solve the kinetic energy here. So KE is equals to 1.5. Okay. So should be 21 mv2 v squared. So KE is equals to 21. Okay. 21, then 1. Okay. Then negative 2 sine. Okay. Times 3 minus 2, then 2 squared, and then that will come up to kinetic energy 1.42 joules. Okay, so here is the final answer for the number 2. Okay, let me highlight that. Okay, so so now we will go to the question number 3. So the fuel used a car is defined by F multiplied by X is equals to 3x squared divided by 80 minus 6x plus 245. So where x is the traveling speed in kilometers per hour. So what is the most economical speed of the car? In other words, determine the speed of the car which uses the least amount of fuel. Okay, so for that one, we will be using that formula. Okay, so so here we ask to determine the speed that will use the least amount of fuel. To do that, we're going to get the derivative of the function and equate to 0. Hence, the speed that minimizes fuel intake is 40 kilometers per hour. So let's check for that. So we'll be using the computation for this. Squared 245. Okay. So to minimize this function, we set the derivative fx to 0. So it should be okay 2. So and then 3x squared divided by 80 should be a 0, 3. Then let's go and put x here. So this x and then minus 3, I guess. Yeah, 3. So let's copy this one. So 403 x minus 3, then 0 is equals to 403 x minus 3, and then now we will be solve the speed that optimize the fuel intake. So it should be x is equals to 40 kilometers per hour. So now this is the answer for the number 3. Okay, so now let's go to the number 4. Okay, oops. So the sum of two positive numbers is 30. One of the number is multiplied by the square of the other. If each other is greater than 0, find the numbers that make this product a maximum. So right now we let x be the first positive number and y be the second positive number, which is equals to 30. Okay, so let's so it should be x plus y is equals to 30. So in order for us to maximize the product of the first number and square of the second number, we set this value as p and set its derivative to 0 with the value of x or of y to be 30 minus x. Okay, so letter p, and then oops, x y to the square. Okay. Okay, so that's gonna be the first number. We should maximize the product of first number and square of the second number, so we set this value as p. By the way, let's make it p instead. Yeah, it's p. So to maximize p, we set its derivative to 0, but before that, make sure that p is in term of a single variable from the first equation. Okay, so for that, so it should be x times 30 minus x squared. Okay, and then so let's compute that. X is equals to 900 minus 60x plus x squared. Okay, so now p is equals to squared, yeah, 900x minus 60x squared plus x to the third power. So take its derivative and set it to 0. So first derivative is equals to 900 minus 120x plus 3x squared. Okay. 0, since we will be setting this as a 0, is equals to 900 minus 120x plus 3x squared. So x squared minus 40x plus 300 is equals to 0. Okay. So right now let's go ahead and factoring this one. So x is equals to 30 and x is equals to 10, then equals to 0. Okay, so the value of x, it should be 30 and x is equals to 10 as well. Okay, So if x is equals to 30 and y is equals to, so let's type this, if x is equals to 30 and y is equals to 0, because their sum is 30, so that's why we need to put that here. So and x is equals to 10 minus y is equals to 20. So the two numbers should be greater than 0. So therefore, the only acceptable solution is 10 and 20. So 10 and 20. So yeah, that's the only acceptable solution for that. So yeah. Okay. So now we will go to the um next one. So oops. So a wooden block is made as shown in the diagram. So the ends are right angled, triangled, having side 3x and 4x and 5x. The length of the block is y. The total surface area of the block is 7,200 cm per second. So find the length each side of the wooden block. So let's go ahead and solve that one. Oops. Okay. Alright. Let's check. Alright. So right now, in order for us to get that, we'll be putting here, okay, SA is equals to 2, which is the area of rectangle or the base, okay, plus the area of lateral rectangular faces. Let's check. Rectangular faces, okay. Areas of lateral rectangular faces, okay. And this one too should be area of triangle or the base, okay. So now let's go ahead and compute that. So 2 equals 21 times 3x, okay, and then 4x, 4x plus 3x times y plus 5x times y plus 4x times y. Okay. So the SA would be, okay, SA is equals to 12x squared plus 12xy. So 12x squared plus 12xy, so it should be 7,200 cm squared. Okay, so that's correct. Talk to surface area. Yeah, that's the one. So the volume is given by V is equals to A base H. Okay, so this one. Okay. So it should be v is equals to 21 3x 4x and then the y. So the velocity will be velocity is equals to 6x squared y. So to optimize the value of volume, set its derivative to 0. So solve first the value of y in terms of x using the SA solve. Okay. So now we'll be doing the computation here. 12x squared plus 12xy is equals to 7,200 cm squared. Then y is equals to 12x 7,200 minus 12x squared. So now we'll be computing the x is equals to x 600 minus x. So now we will be substituting the to volume equation. So x is equals to 6x squared y. So velocity will be 6 squared. Then x 600 minus x. So the velocity will be 3600x minus 6x to the third power. So now we'll be getting the derivative. So the velocity 3600 minus 18x squared, that's 0, is equals to 3600 minus 18x to the second power. Should be 18x squared is equals to 1600. So we'll be substituting this. So and then x is equals to 102. Yeah, this is the correct one. So solve for y. Okay, this one. So now y, sorry, it's red. Back. So y x 600, y is equals to x 600, and then x is equals to, so we'll be multiplying that 1600 minus 102. So the y is gonna be 202. So that's gonna be the answer for the number 5. Okay. 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 Yeah. So yeah, that's gonna be it for today. So I hope you get all the information. So now, thank you and have a great day, have a blessed day. Thank you.